why did I assign that? What am I trying to get you to do? I'm trying to see if your vocabulary, do you know what isosceles means? That's one of the things I'm testing with this problem. What else? I'm testing your constructions that you did earlier in the unit. Who knows how to do this? Who could come up and, do you want to come up? Here's our, I think we've got all of our tools. Straight edge, where's the, oh, down here's the compass. Don't want to try it? You just want to talk about it?
I can just say it, yeah. I was like,
Okay. Do you want to come try it? Yeah. While she's coming up, give the introduction. What is there? What's the trick?
You have to use 90-degree angles because you know how to make those.
You do?
Well, you have to know how much is left over for 180 in a triangle after you subtract out the 135. And then you have to know that an isosceles triangle has two angles that are the same. Since a 135-degree angle is obtuse, the other two angles are going to be acute, which when you subtract 135 from 180, it's 45. So you know that they're going to be each half of 45, since they're going to be the two that are the same, rather than the third angle.
Everybody follow her what she was saying there? Okay.
Okay.
So she already knows what the size of the other two angles are besides the 135, because she used her triangle sum property. All right. This is not as easy to use as
Are you going to keep explaining this is how you did it?
I'm trying to make sure. Because I did.
Talk to us about what you're doing and why.
Okay, so I started with a straight line, which we know is 180 degrees. And then I did some quick calculation. I said, okay, what's 100, what can we do? How can we make 135 degrees using what we know? So 135 is a 90-degree angle and a 45-degree angle. Well, we know how to make 90-degree angles because we can make perpendicular bisectors of the line. And so a perpendicular bisector of a straight line would be 90 degrees on both sides. Then I said, okay, well, we know how to construct an angle bisector, so now we just have to bisect one of those angles, and that's going to be 45 degrees. So then we can do the 90 degrees and half of the next angle, and that would be 135 degrees.
Okay, so what have you got done and what's that accomplishing for us?
So this will be the perpendicular bisector. I had to move my line because it was too tall.
And you're connecting the intersection point with what?
The point that I was trying to. Well, because I picked this point, but it was too long, so it would be off this.
Okay.
If you don't want to have to pick a point on your line, if you do the same thing down below, then you'll end up where your 2 points that you use as, I can't remember what it's called, they're really sharp. And
In other words, there's more than one way to make a perpendicular, right?
Okay.
So there's two 90s.
We have so then we can just choose one side to bisect. So, we do bisectors,
You're gonna choose the right side.
and I'll do it down below.
Which one of those is your mark?
This middle one.
Okay.
is Scarpy.
Okay.
Then you connect the vertex to the intersection of the two
And that should be a what? An angled bisector, right? Since that was a 90, she's now got a 45.
And then, this is the easy part, you can make this line however long you want it. Just say that. And you make this line. Same length.
Except a straight edge, by definition, does not use the marks on the side. That would turn it into a ruler.
We can cheat.
So she's using a ruler to get her isosceles part, and that's not using the traditional tools. So she measures there, and if she doesn't change her measure or her adjustment, now that's the same length, and that's just as good, maybe faster. So this is how big? 135, because it's 90 plus half of the other one. And Rachel said these two are how big?
Half of 45.
Half of 45, because that's what's left, right? So 22 and a half. If we were to get our protractor out and measure them, that's what they would be. And we know, what would, if this were a test question, what would I be looking for? I would be looking for all the tracks. Don't ever erase any of your construction tracks. I got to see where you went. I've got to see that there was an arc here, and then you moved your thing and did an arc out here. I've got to see all of that. I've got to see this arc measuring off equal lengths so that I know you know it's isosceles. That's how I can tell you know how to create an isosceles triangle. Okay, don't erase any of your marks. Okay? Questions? That one was one that it required some extra thinking. It was a fairly difficult problem. Did you know enough to be able to do it though? Yes, it's just some of us aren't quite used to, oh boy, so there was vocabulary involved, there was constructions involved, plus there was this thinking of how can I get a 35-degree angle size? Okay? So what size angles can we construct?
30, 60, 90, or 85.
We can get 90s, right? We can get 60s. How can we get 60s?
I just know it's possible. I don't know how to do it personally. I just know it's possible.
How would we do a 60-degree? Yeah.
Well, you know 60 is 2/3 of 90,
Yeah.
right? So you would take the angle bisector, you would make that, and then you would bisect the angle bisector, if that makes sense. And
Well, if
take
you-
the bigger part.
So bisect what? A 90?
Yeah, bisect the 90.
Will
and
give
then
you a 45.
And then you bisect the 45.
That'll give you a 22 and a half.
Wow. My thinking was wrong. Let me rethink that.
Okay? But you're thinking, and that's good. Anybody think of how you might make a 60-degree angle? Ben claims it's possible. Yes, Kim?
you can use what you know about triangles, 180 divided by 360
180,
degrees in a triangle. So if you make an equilateral triangle,
can you make an equilateral triangle with your compass and straight edge? Yes. Let's let that be one vertex. Let's let that be another vertex, that distance, okay? And then we'll come up here and say, wherever those, does everybody see what I've done? I haven't moved my compass once, so that length is the same as that length, which is the same as that length, which makes it what? Equilateral. And every equilateral triangle is also equiangular. So there are the you gotta account for the width of your chalk or the width of your pencil. If you don't have a sharp pencil, that should be 60, 60, 60. So we can make 90s, we can make 60s, we can make 135s. What else could we make?
Well, we can bisect those 60s.
Now we can bisect the 60s so we could get 90s, right? So we could actually get a bisected 60, get a 30,
We wanted to
and
bisect that.
put it with a 90 to get
120.
120 if you wanted to. You could do that. Okay. So you just need to be a little bit creative and think about now, how can I put those 90s, half of 90s, 60s, half of 60s, how can I put those all together to make the various sizes I need? What else on the homework? Anybody else have any questions about any of the homework problems? That was probably the toughest. How did you do the earthquake epicenter location? How'd you do it?
I drew lines in between each of the points, and then I don't know if your terminology right, but I did an angle bisector for each one, and then from the center.
Why would that be it?
Why would what be what?
She said she connected the three cities with straight lines, segments, made a triangle. It was between, what was it, Pocatello and Afton and Rexburg. Okay? So there was our triangle, and then she bisected the angle, is that what you said?
I know why it worked.
All right. Here's Rexburg, here's Pocatello, and here's Afton out here, right? If we drew angle bisectors, they would all intersect in the same spot, right? What would that be?
Equal to the sides.
The intersection of the angle bisectors is the incenter, and the incenter by definition is what? Center of the inscribed circle. That's where its name comes from, incenter. So that would mean there's a circle in here, and it is the center of it, right? Is that the right location?
Well, I understood it to mean that, like, so they measured each, like, 60, 60, and then it was, like, 25 or something. And so I understood it, that it was 60 away from it, so, like, no matter what, that was where it was. It wasn't where they intersected. It
Mm.
was where that was 60, this one was 60, and then the last one was 25 or something. So I understood it to be not the center of the triangle, but just where those three could meet, like the end of them.
Or is it the circumcenter that we want? What's the circumcenter?
Like
The center of the
of where
circumscribed circle. What makes those, by the way? This is really hard to draw. That's terrible, but you get the idea. Try it sometime. What that represents, the distance is the same from the earthquake to all of the cities. Is that true? No. So it wouldn't be the circumcenter, which we get by making the perpendicular bisectors of the triangle. Yeah.
I was going to say what I did, because they gave you the distance from each one, and so I took the little distance chart thing on it and used my compass and then just did a whole circle around each point, and then wherever they intersected, all three of them, that would be the only place that it could be at.
Does that make sense? Is that what? So it's not a circumcenter, it's not an incenter, it's not a centroid, it's not an orthocenter, it's just three circles that have different radii and looking for where they all intersect at the same point. Did you get them to do that? Did they?
It took me, because I thought it was the longer line, and so I kept doing it and it wasn't working, and then I finally did the shorter line and it finally worked after like the 20th time, but that just confused me. Because I thought that was 20 miles instead of that was 20 miles.
Okay, yeah, the bottom one is the 60 kilometers, is that what, or 50, what is it?
Yeah, 50.
50 kilometers, and the top one's the 20. Okay. So they weren't intersecting before, and then
Yeah,
after you did that, you,
Yeah.
okay. So, how did you get a circle radius? If that one was 20 miles, how did you get the 60?
Because if you make a slash mark, however, like you measure it out with your compass, the 20, set the sharp point at the origin and just make a small slash mark, I can take that and go again and set up my slash mark and I go 20 miles farther out and I can do it again. And then once I've got that distance of 60, then I can expand my compass to get 60 and go in the circle.
If this here was the 20 miles, what we could do is, we could extend this line out. Gotta hold it tight against the. So that's 20 miles from there to there. Then it must be how many miles from there to there? 40, and then I do another one and get 60. Now I open my compass that full amount, and that is where I put my circle around the city. Which one was 60? Both of them were. Okay, so you have your thing set up for both of those. And then to get your 26.2 miles, you're going to have to do some kind of adjusting, right? It'll be 20, it'll be less than half, right? To get that, to find out where that is. Okay.
So when you said use your tools, we were supposed to use our ruler again.
Oh, your ruler's fine.
Okay, like we could have used the measurements.
Yeah. If I say use your traditional construction tools, if I say to construct, the only thing you're allowed is straight edge, no marks on it, and the compass.
Okay.
But no, anything that you wanted to, yeah. In fact, can't you on Google Maps go out and put a place and put a certain distance around it? And you could maybe go out and just use Google Maps to answer this question. When I said tools, I just thought whatever you want to choose. Even technology might work. Okay. Anybody have any other questions? Well, let's get ready to wrap this unit up. And Tuesday we'll launch the next one.